Welcome to the Curious Owl. This is a quiet place for learning at night. Here, knowledge is shared slowly, gently, and without urgency. If you enjoy calm journeys like this, you're welcome to like the video, subscribe to the channel, or share it with someone who might enjoy resting here too. Tonight's video explores calm, timeless facts. Not to stimulate the mind, but to give it something peaceful to rest on. You don't need to remember anything. You don't need to stay awake. Simply let the words move quietly in the background as curiosity softens into rest, and rest becomes sleep. Let's begin. The evening settles into stillness, and the mind begins to return to its natural rest. Out in the vastness of the cosmos, a rhythm has been unfolding for ages, steady, patient, and quiet. There is nothing to chase, nothing to hurry toward, only time, moving on in its own gentle way as we turn our attention to the far reaches of existence. The universe has existed for a length of time that is difficult to hold in the mind, currently estimated at around 13.8 billion years. This immense span has allowed matter to cool and structures to form, slowly and steadily. Long before there were any observers, the earliest energy began to arrange itself into the foundations of everything we see today. Its age is not a destination, but a reminder of quiet persistence, unfolding across countless days and nights. The light that reaches us from the most distant galaxies has been traveling for billions of years. By the time it arrives, it has crossed distances so large they are almost beyond imagination, carrying with it a calm record of a younger universe. It moves through darkness at a constant pace, eventually meeting our atmosphere and offering a view into the distant edges of space. A long journey, completed in silence. Between these far points, it can seem as though there is only emptiness. Yet space is not truly empty. It contains extremely sparse gas, thin veils of dust, and the faint presence of background radiation. These traces drift quietly, separated by immense distances, and still they form a subtle fabric that connects the stars. Even in the deepest dark, there is a delicate persistence of matter, moving slowly under unseen forces. The Milky Way is one such gathering of matter, a vast spiral system holding over 100 billion stars. It turns with measured calm, a slow sweep of light and shadow that has endured for eons. Each star follows its own steady path, and together they shape the soft glow of the galactic disk. This immense arrangement is held by gravity, silent, invisible, and constant. In one of the outer regions of this spiral lies a quieter branch known as the Orion Arm. Our sun is situated here among the stars of this part of the galaxy. It is a calm location, far from the denser, more active center. Here, the stars are spaced with generous distance between them, and the whole arm drifts slowly around the galactic core. In colder, darker regions of these spiral arms, stars begin their existence inside dense clouds of gas and dust. These places, often called stellar nurseries, are regions of quiet transformation. Deep within the cold shadows, gravity draws material together, layer by layer, over millions of years. There is no sound, only gradual gathering, growing pressure, and the slow approach toward ignition, until a new light emerges from the stillness. When you look up on a clear night, almost every star you can see belongs to our own galaxy, the Milky Way. These points of light are our nearer neighbors in the vastness, shining with calm steadiness. They are part of the same spiral structure we inhabit, scattered across our local region like distant lanterns, quiet markers of our immediate surroundings in space. The nearest of these neighbors beyond our Sun is the Alpha Centauri system, about 4.37 light-years from Earth. Even this near distance is vast, requiring years for light itself to cross. It is a triple star system moving through darkness in a slow gravitational dance, close in cosmic terms and still deeply distant. A light year is a way of measuring that distance, how far light can travel in 1 year. It is roughly 9.46 trillion kilometers. The scale is far beyond everyday experience, and yet the measure is simple: light, moving steadily, mapping the vast quiet between stars. Because light takes time to travel, the night sky is always a view into the past. The light you see tonight may have left its source hundreds, thousands, or even millions of years ago. Looking upward becomes a calm connection to earlier moments of the cosmos, signals arriving now, long after they began their journey. The formation of the Sun began roughly 4.6 billion years ago within a rotating cloud of gas and interstellar dust. As the cloud slowly collapsed, it spun faster, flattening into a disk, while the center grew denser and warmer. Over time, gravity continued its steady work, gathering material until ignition became possible. What formed was a stable source of light and warmth, an anchor for our local system, enduring across vast stretches of time. Current observations suggest that almost every star visible in the night sky likely hosts at least one planet. Planetary systems appear to be common, as though world-building is a natural part of a star's life. For nearly every point of light above, there may be a hidden family of planets moving through darkness, each following a rhythmic orbit, steady and unseen. In our own neighborhood, the solar system has 8 major planets, yet it extends far beyond the familiar names. Past Neptune lies a cold region populated by many smaller dwarf planets. These distant bodies move slowly, where the sun's influence is faint and the stillness is deep. The system remains orderly, each object following its path through the quiet vacuum. Between Mars and Jupiter lies the asteroid belt, filled with fragments and rocky remnants from the solar system's earliest days. These pieces never formed a full planet. They remain as quiet travelers spread across a wide band, separated by enormous spaces that make the region feel sparse and calm. They are ancient witnesses, continuing their slow orbit around the Sun. Jupiter is so massive that its presence is felt throughout the solar system. Its gravity influences other planets and smaller bodies, helping shape and stabilize their movements. Its scale is hard to picture, and yet it moves with quiet grace, rotating quickly while following its long orbit around the Sun. Its influence is constant, a silent weight within the planetary family. Saturn is known for its intricate rings, composed mostly of water ice and small rocky particles. The rings are not solid sheets, but countless individual pieces, ranging from grains of sand to objects as large as mountains. In distant sunlight, they form a soft, luminous halo. Despite their breadth, the rings are remarkably thin, orbiting in an elegant plane. Farther out, Uranus spins with an unusual tilt, almost on its side. This orientation is thought to have resulted from a massive collision long ago during its early formation. Today, it moves through its long seasons with quiet peculiarity, a pale blue world following its path at a measured pace, far from most disturbances. Neptune, the most distant of the major planets, appears deep blue. Methane in its upper atmosphere absorbs red light and reflects blue wavelengths back into space. Its atmosphere is cold and vast, with winds moving through high clouds. Neptune marks the edge of the major planetary zone, calm and distant at the boundary of the familiar. Beyond Neptune, the solar system may extend far farther than we can easily picture, into the Kuiper Belt and the theoretical Oort cloud. In these outer reaches, space is extremely cold. The sun becomes little more than a very bright star, and motion is measured in centuries and millennia. It is a vast shell of icy material surrounding the inner system in quiet, frozen calm. From time to time, comets descend from these distant regions. As they approach the sun, ice transitions into gas, releasing dust that forms a glowing tail. The tail points away from the sun like a soft brushstroke across the dark. Comets are temporary visitors, following long paths that eventually return them to deep cold, a slow cycle between warmth and stillness. The moon, Earth's quiet companion, likely formed after a massive collision in the early history of our planet. Debris from that event settled into orbit and gradually gathered into the moon we see today. Over time, chaos gave way to order, and the moon's steady cycles began, guiding Earth's nights for billions of years. The far side of the moon is sometimes called the dark side, but it is not permanently in shadow. It faces away from Earth and has its own day and night as it orbits. Because the moon rotates in synchrony, one side remains turned toward us, while the other is hidden from view. It is a landscape of craters and dust, quiet and solitary, still touched by the same sunlight in its time. On Earth, gravity is the gentle, constant force that shapes the world. It allows oceans to settle, mountains to remain grounded, and air to move as it does. It brings stability and weight, creating a reliable foundation for life. It is an invisible anchor, keeping the natural world balanced and predictable. In space, that familiar pull becomes what is known as microgravity. In this environment, the sensation of weight fades and objects drift with slow, effortless grace. Movement becomes gentle and floating, quietly redirected rather than pressed down. It is a different kind of stillness, shaped by the absence of a strong downward pull. The vacuum of space is also a place where sound cannot travel. Without a medium, vibrations have nowhere to move. This creates a natural silence, deeper than anything on Earth. Planets can move, stars can burn, entire galaxies can rotate without a single sound. The stillness remains. The Milky Way itself is slowly rotating. It takes roughly 230 million years for our galaxy to complete one turn around its center. This motion is too large and too slow to feel, yet every star and planet is part of it. We drift through space in a long, quiet journey, spanning eras far beyond human time. In the distant future, the Milky Way and the Andromeda Galaxy are expected to meet. They are moving toward one another across intergalactic space, drawn by gravity. The encounter will be gradual, unfolding over billions of years. Stars are so widely spaced that they will likely pass one another without direct collisions, eventually settling into a new, larger structure, another calm rearrangement of the cosmic neighborhood. Across the universe, galaxies appear in many shapes. Some are spirals with sweeping arms. Others are ellipticals, soft and rounded, filled with older stars. Some are irregular, arranged in patterns without symmetry. Each form reflects a different history, matter organizing itself under time and gravity, creating a quiet variety of light. At the heart of many galaxies, supermassive black holes reside. They can be millions of times more massive than our Sun, yet contained within a relatively small region. They sit as deep gravitational anchors, influencing the motion of nearby matter. Their presence is known through the way surrounding stars and gas move, held in silent patterns around an unseen center. A black hole's gravity can become so strong that it creates a boundary from which nothing returns. Past a certain point, even light cannot escape. This produces a region of perfect darkness, quiet, complete, and unseen. It is a place where familiar expectations reach their limit, and gravity becomes absolute. That boundary is called the event horizon. It is not a surface, but a threshold, an invisible edge in space-time. Beyond it, paths outward no longer exist. To an outside observer, something approaching the horizon would appear to slow and fade, settling into the stillness that defines the black hole. Black holes can also spin at extraordinary speeds. This rotation twists the fabric of space and time nearby, a silent shaping of the environment without friction or sound. Nothing close remains entirely still. The local space itself is gently drawn into motion, revealing how gravity can shape not only matter, but the structure of space-time. In 2019, astronomers captured the first image of a black hole's shadow. It was the result of global coordination, telescopes working together to observe the center of a distant galaxy. The image revealed a dark circle surrounded by a soft ring of light, a quiet confirmation of long-held understanding, made visible at last. Stars like the Sun do not vanish. Over time, they leave behind cooling remnants known as white dwarfs, dense cores revealed after the outer layers are shed. A white dwarf no longer generates energy. It simply releases stored warmth slowly into space over immense spans of time. A long, quiet twilight, one final chapter of steady cooling. For much larger stars, the end can involve a supernova, an explosion that occurs when the star can no longer support its own weight. The star collapses, then rebounds, scattering material into space. The event itself is powerful, but what follows is slow, expanding clouds of gas drifting outward, enriching surrounding space with the building blocks of future worlds. Elements released by these ancient explosions, carbon, oxygen, iron, can drift for millions of years. Eventually they become part of new clouds of gas and dust, gathered into forming stars and planets. This is a patient recycling on a cosmic scale, old matter becoming the foundation for new structures again and again. The iron in Earth and the oxygen in the air have traveled long, quiet paths through time. In this way, everything on Earth is made from material formed in stars long ago. The connection is physical and enduring, a continuity that can feel peaceful. Nothing truly disappears. Matter changes form, moving from stellar cores into the quiet stability of planets, persisting across the ages. Stars also vary in how they shine. Some remain steady for billions of years. Others pulse or flicker, changing brightness in rhythmic cycles. These variable stars expand and contract like a slow celestial breath, waxing and waning in predictable patterns that continue quietly in the dark. Among the most remarkable are pulsars, rapidly rotating neutron stars that emit focused beams of energy. As they spin, the beam sweeps through space, creating regular flashes as seen from Earth. These pulses can be extraordinarily consistent, marking time with steady precision. Even far away, their rhythm remains reliable. Neutron stars are extremely dense remnants of massive stars. Matter within them is compressed into a state unlike anything on Earth. A teaspoon of neutron star material would weigh billions of tons. Their gravity is immense, second only to black holes. They exist as small, heavy spheres, silent, intense, and enduring. The cosmic microwave background is a faint glow left from the earliest moments of the universe. It is the afterglow of the Big Bang, cooled and stretched over billions of years into a subtle presence that fills the sky. It does not demand attention, it simply remains, quiet, steady, and everywhere, resting beneath the stars as a soft reminder of beginnings. This background exists in every direction, a constant fabric of early history. It is like the faintest trace of warmth lingering long after a fire has faded, still present in the air. It carries the story of how everything began, providing a calm backdrop to the movement of galaxies and the long lives of stars. The universe has no single center. Instead, it expands evenly in all directions. It can help to imagine not objects moving away from a middle point, but the space between things gently growing larger. Expansion happens everywhere at once, smooth and continuous, creating a sense of balance in the cosmic fabric. Because of this stretching, distant galaxies appear to move away. As space expands, the light traveling through it stretches as well, shifting toward redder wavelengths. The effect is gradual and steady, a quiet signature of the universe's ongoing change, slow motion on the grandest scale. What we see with our eyes is only a small window into the whole. The visible stars are a tiny fraction of what exists beyond our reach. Our view is like a calm garden within an endless landscape. Knowing there is more beyond the horizon can feel spacious rather than overwhelming, allowing the mind to rest inside a larger sense of scale. It is estimated that there may be more galaxies in the observable universe than grains of sand on Earth's beaches. Each galaxy holds its own vast collection of stars, worlds, and moons. The numbers become difficult to hold, and still each galaxy moves in its own quiet region of space, separated by great distances, drifting through darkness. The observable universe is about 93 billion light-years across. This is the region from which light has had enough time to reach us since the beginning. It is a boundary shaped by the speed of light and the age of the universe. Within it, galaxies rotate, matter drifts, and time continues its long unfolding. Beyond what we can observe, space likely extends farther still. There are regions so distant that their light has not reached Earth. They remain beyond our current horizon, existing in quiet distance. The universe may extend far beyond what we can map, resting in a calm unknown. Cosmic dust is made of tiny solid particles drifting through space between stars. Often smaller than a grain of smoke, it still shapes the night sky. Dust catches and scatters starlight, creating gentle veils and shadows. It is a fine presence, waiting to be gathered into new worlds, or simply to drift on as a silent witness. Nebulae are vast clouds of gas and dust, softly glowing as starlight passes through them. Some shine with their own light. Others form dark silhouettes against brighter backgrounds. Over millions of years, they change slowly, forming quiet landscapes where the universe prepares for future cycles of star formation. The Orion Nebula is one of the closest stellar nurseries to Earth. To the naked eye, it looks like a faint, fuzzy patch of light, yet within it, gravity is gathering hydrogen gas into new suns. It is a place of gradual transition, where stillness becomes the first hint of emerging light, visible in our sky for as long as humans have looked upward. Some nebulae are not beginnings, but endings. As certain stars reach the close of their steady lives, they release their outer layers, forming delicate patterns of drifting gas. Soft rings and wisps expand into the void at a measured pace. Light becomes dispersed, and the star's final chapter appears as a quiet veil of color and shadow. Between stars, interstellar gas moves in gentle currents. It is extremely thin, flowing across light years like an invisible tide. Guided by gravity and the pressure of starlight, it drifts without resistance. This interstellar medium connects distant systems, a quiet reservoir of material shared across the galaxy. The center of the Milky Way is hidden from direct view by thick clouds of dust. Visible light cannot pass through easily, but radio and infrared signals reveal a dense core where stars gather closely. It is a region of steady activity, mostly unseen, present behind a curtain of darkness. Within that hidden center lies a supermassive black hole known as Sagittarius, a star. It is millions of times more massive than the Sun, occupying a relatively small region of space. It anchors the Milky Way's inner motion, guiding the paths of stars through gravity alone. A silent heart, heavy and deep. In strong gravitational fields, time itself behaves differently. Time flows more slowly near massive objects than it does farther away. Near a black hole or a dense star, seconds stretch, taking on a heavier rhythm. Time dilation is a reminder that the universe keeps many quiet tempos, shaped by mass and distance. Light also responds to gravity, bending as it passes large objects in a phenomenon called gravitational lensing. When light travels toward us from a distant galaxy, it can be gently curved by intervening matter. The universe becomes a natural lens, redirecting ancient light and revealing distant structures in soft, altered ways. This lensing can create distortions, arcs, rings, or multiple images. These are quiet optical effects shaped by mass, giving us glimpses of objects otherwise too distant or faint. Reality appears gently reshaped, and the hidden structure of gravity becomes visible through light. The faintest galaxies captured by sensitive telescopes show the universe as it was in its youth. Their light left billions of years ago and arrives now as small, soft signals. Observing them is a way of looking back through time, witnessing early stages of cosmic structure from a calm distance in the present. Across time, stars form, shine, and eventually pass away. In doing so, they enrich the universe with heavier elements. Simple early gases are transformed inside stellar cores into materials that make planets possible. It is a slow, enduring cycle, one that quietly increases complexity over vast ages. Those forged elements, oxygen, carbon, nitrogen, eventually become part of new worlds. They settle into planetary crusts and atmospheres, becoming the substance of landscapes and air. Every solid thing has a history that reaches back through the stars, a quiet inheritance carried forward. Cosmic rays also travel through space, high-energy particles moving near the speed of light. They originate from distant supernovas and other events, crossing great distances before sometimes reaching Earth's atmosphere. Their arrival is subtle, mostly unnoticed, a gentle reminder that the cosmos remains active even in deep quiet. The sun's energy is produced through nuclear fusion. In its core, pressure is so great that hydrogen nuclei merge into helium, releasing energy. That energy moves outward slowly, finally reaching space as the light and warmth we know. The process is stable and enduring, and has continued for billions of years. Each second, the sun converts approximately 600 million tons of hydrogen into helium. The scale is immense, yet the process remains hidden deep within, steady and consistent. This quiet rhythm supports the balance of the solar system, radiating outward into surrounding darkness. Sunlight takes about 8 minutes to travel from the sun to Earth. When morning light arrives, it carries a small connection to the recent past, a silent journey across millions of kilometers, completed with calm reliability, settling on the surface of our world. Sunspots appear at times as darker regions on the sun's surface. They are cooler areas created by magnetic activity that affects the flow of heat. They move slowly with the sun's rotation, appearing and fading in cycles that span years, subtle shadows on a vast field of light. A stream of charged particles called the solar wind flows outward from the sun. It moves through the solar system like an invisible tide, filling the space between planets. It interacts gently with magnetic fields and keeps the space between worlds from ever being truly empty. When these particles reach Earth, the planet's magnetic field guides them toward the poles. There they interact with the upper atmosphere and create auroras, silent curtains of light that drift through the night. Their movement is slow, fluid, and soundless, a visible response to energy arriving from the sun. Aurora colors depend on atmospheric gases. Collisions with oxygen can produce green or red light, while nitrogen can create blue and violet tones. These colors blend high above the ground, forming luminous patterns in the thin polar air, a quiet chemistry made visible. Across the universe are vast regions called cosmic voids, where few galaxies exist. These are immense stretches of space where matter is sparse, deep intervals between denser filaments of the cosmic web. In such places, distances between points of light are even greater, and the darkness feels broader. Cosmic voids can span hundreds of millions of light years. They are regions where very little happens, quiet expanses between more active structures. They emphasize scale, offering contrast and balance within the overall architecture of the universe. Between voids lie filaments, long strands of galaxies and dark matter forming the cosmic web. Matter tends to gather where filaments intersect, creating clusters. These threads stretch through the dark like a quiet framework, holding the universe in a connected pattern on the largest scale we know. Dark matter does not emit, absorb, or reflect light. It remains invisible, known only through its gravitational influence. It provides extra mass that helps keep galaxies bound as they rotate. Though unseen, it acts as a quiet foundation, shaping how structures hold together. Most matter in the universe is dark matter, outweighing visible stars and gas. The familiar world of light is only a small portion of what exists. This can feel humbling, a reminder that much of reality is silent and hidden, guiding the visible cosmos through gravity alone. Dark energy is even more mysterious and is thought to drive the universe's accelerating expansion. While gravity draws matter together, dark energy acts as a persistent outward influence, widening the distances between galaxies. An invisible presence, calm, and pervasive, shaping long-term change. The universe's ultimate fate depends on the balance between gravity and dark energy. The outcome unfolds over immense spans of time. If dark energy remains dominant, expansion continues, and galaxies drift farther apart into quiet distance. The story is written slowly, over trillions of years. Some models suggest expansion will continue indefinitely, with the universe growing colder and more diffuse. Galaxies would separate until they become invisible to one another. Stars would eventually exhaust their fuel, and the cosmos would settle into a deeper stillness, an extended cooling into darkness. Other models imagine cycles of collapse and renewal. Expansion could slow and reverse, leading to a return toward a denser state, followed by another beginning. In such views, the universe breathes over eons, expanding and contracting across timeless stretches. In modern understanding, space and time are woven together into space-time. It is the stage on which cosmic events unfold, continuous, flexible, responsive. Thinking of space-time is like seeing a quiet, four-dimensional landscape in which every location and every moment are linked. Mass and energy curve this fabric. That curvature is what we experience as gravity. Planets follow the curves around their stars, moving in predictable paths because the geometry guides them. The universe moves with mathematical grace, shaped by the gentle bending of space itself. Gravity is often spoken of as a force pulling things together, yet it can also be described as the natural motion along curved space-time. A massive object creates an indentation, and other objects follow the paths that curvature creates. A shift from pulling to guiding, quiet and elegant. Through Albert Einstein's theory of relativity, we learned how deeply space and time are connected. They are interwoven, not separate. Changes in space relate quietly to changes in time. The universe remains one coherent whole, a single fabric of distance and duration. This means time is not the same everywhere. In stronger gravity or at high speeds, time slows slightly. A clock near a massive body would tick more slowly than one far away. The pace of time becomes a reflection of environment, moving with the weight and motion of the cosmos. In the earliest universe, matter and energy were not arranged into stars and galaxies. Everything was spread in a hot, dense state. Over time, as expansion continued, cooling allowed structures to form. What began as a uniform glow gradually developed small variations, seeds for future galaxies. As the universe cooled, tiny fluctuations grew. Gravity gathered matter into slightly denser regions, and over billions of years, those regions became the first galaxies and clusters. A slow transition from simplicity to structure, unfolding in patient steps. Expansion continues today, increasing the distances between galaxies. It does not pull apart solar systems or galaxies internally, because local gravity holds them together. Instead, it stretches the space between large structures, a long measured breadth across intergalactic emptiness. Since the earliest moments, the universe has cooled as it expanded. The average temperature now rests close to absolute zero, a peaceful consequence of growth, leaving behind a cold, stable background for the long lives of stars. The coldest regions of space are far from any star, only a few degrees above absolute zero. Molecular motion nearly stops, and the environment becomes near perfect calm. These places represent extreme stillness, quiet corners where the early heat of the universe has faded into almost complete cold. Light is massless, yet it carries energy and momentum. It moves as a silent messenger, connecting distant suns and worlds. It can exert gentle pressure, influencing dust and shaping comet tails. Even the most delicate parts of reality leave measurable traces. Every photon travels through vacuum at the same constant speed. This speed is a fundamental limit, steady regardless of source or observer. It becomes a quiet pulse of the cosmos, defining how time and distance relate and how signals from stars arrive with reliable grace. Many stars exist in binary pairs, orbiting each other around a shared center. From far away they may look like one light, but close observation reveals two bodies, their paths linked for billions of years. A quiet partnership repeated across the galaxy. Other stars gather in globular clusters, dense spherical groups containing hundreds of thousands of ancient stars. They are among the oldest structures formed early in galactic history. Within them, stars sit much closer together than they do near our Sun, creating a sky of layered glow. Globular clusters often orbit in the outskirts of galaxies, in the halo surrounding the main disk. Their journeys are slow and patient. From their distant vantage point, they witness the steady motion of the galaxy below, remaining separate from dense gas and dust. The smallest galaxies may hold only a few million stars. These dwarf galaxies can be dim and difficult to detect, drifting near larger systems. Yet they remain complete structures, governed by the same laws of gravity and time, holding their quiet place in the cosmic map. The largest galaxies can contain trillions of stars and stretch for more than 1 million light-years. Often found at the centers of galaxy clusters, they grew through mergers over billions of years. Their scale is immense, and their presence feels like a quiet accumulation of time. Cosmic time is not a single uniform flow. It varies by location, near massive objects, or in emptier regions. Each part of the universe keeps its own quiet rhythm, overlapping with others. A universe of many tempos, held together by space-time. A star's color reveals its surface temperature. Cooler stars appear red. Hotter stars appear blue-white. Red stars often burn slowly and can last for tens of billions of years. Blue-white stars are more intense and shorter-lived. Together they create a soft palette across the night sky. Most stars visible to the naked eye lie within a few thousand light-years. Beyond that, the galaxy continues far farther than we can see without instruments. Our constellations are drawn from a local neighborhood, familiar patterns formed by nearby lights. Light travels through space long after its source may have changed or faded. In the emptiness, there is little to stop it. Photons continue onward, carrying the record of earlier brilliance. Even in deep night, the past remains in motion, quietly traveling. In every direction, the universe extends, vast, calm, and unhurried. Galaxies rotate, dust drifts, gravity holds structures in place, and time continues its steady movement. The cosmos does not hurry, it simply unfolds. The physical world is shaped by subtle constants and hidden structures, holding the heavens in quiet order. Beyond visible light, deeper layers continue their patient work, forming the background of every night. All the matter we can see, stars, planets, and gas, makes up only about 5% of the universe. The rest is dark matter and dark energy, unseen yet influential. The visible world becomes a thin surface of light on a much larger hidden reality, stable, silent, and deep. In the final moments of massive stars, The heaviest elements can be created, gold and platinum among them, during supernovas or the merging of neutron stars. That material is scattered into space, and over time it becomes part of new planets. Every fragment of gold on Earth has a long history, traveling from a distant event into the quiet ground. Magnetars are a rare type of neutron star with extremely strong magnetic fields. These fields are far more powerful than Earth's, and yet the magnetar itself remains a small, dense object, turning quietly in the dark. At times it releases bursts of energy, subtle signals across space, a quiet limit of magnetic force held within a compact form. In the intergalactic distances, there are rogue stars that do not belong to a galaxy. They were likely ejected long ago through gravitational interactions and now travel alone through vast, empty regions. They shine with steady light, but with no neighbors for millions of light years, silent travelers in deep solitude. Light also changes as it crosses the expanding universe. This is cosmological redshift. As space stretches, light waves lengthen, shifting toward red. The change is gradual, happening over long journeys, and it becomes a quiet record of the universe's growth. A light echo occurs when a sudden flare reflects off surrounding dust. Light travels outward, meets the dust, and then returns toward us later, creating the appearance of a glowing shell expanding. It is a lingering trace, a visual ripple that continues after the star has returned to calm. Inside dense star-forming clouds, molecules such as water and simple organic compounds have been detected. They drift in cold darkness, sheltered from harsher radiation. They are early building blocks of chemistry, present long before any planet forms, quiet ingredients waiting within dust and gas. The great attractor is a gravitational anomaly toward which our galaxy and many others are moving. It is a region of immense mass, pulling across vast distances. Our drift toward it is slow and measured, shaping the motion of our local supercluster over long spans of time. Neutrinos are nearly massless particles that pass through almost everything. Trillions from the sun pass through your body each second, leaving no trace. They move at near light speed, ghost-like and quiet, abundant messengers that connect the sun to Earth in a continuous, unseen stream. The cosmic dark ages describe a period after the early glow faded, before the first stars began to shine. For hundreds of millions of years, the universe was unlit, filled with cooling gas and the quiet pull of gravity. During that time, structures slowly formed in darkness, preparing for the first starlight. The transition into the era of light was gradual. Stars formed, galaxies grew, and the universe became more intricate. And still, beneath all activity, the deep rhythm remained patient and steady. Hydrogen is the most abundant element in the universe. It formed early and remains a primary ingredient of stars and interstellar clouds. It is a simple foundation, fueling cycles of stellar birth and rebirth across billions of years. Within cold molecular clouds are prestellar cores, the earliest stage of star formation. These regions can rest in near balance before collapse begins. Gas becomes extremely cold, movement slows, and the quiet preparation continues for long periods before ignition becomes possible. The most common stars are red dwarfs, small, cool, and extremely long-lived. They burn fuel slowly and can shine for trillions of years. Their steady endurance suggests they may be among the last lights remaining in the far future of the cosmos. Brown dwarfs sit between planets and stars. They are more massive than Jupiter, but not quite massive enough to sustain fusion like true stars. They cool slowly and emit faint infrared light, drifting through the dark in a kind of permanent twilight. The galactic habitable zone refers to regions in a galaxy where conditions may be more favorable for stable planetary systems. It suggests a balance, far enough from intense radiation at the center and close enough for heavy elements needed to form solid worlds. Our Sun is thought to reside in such a region. In interstellar space, polycyclic aromatic hydrocarbons, or PAHs, drift as soot-like particles. They are resilient and thought to hold a significant portion of cosmic carbon. When energized by starlight, they glow faintly in infrared, a subtle hum of organic chemistry. Exozodiacal dust is fine material orbiting other stars, similar to dust within our own solar system. It can be created by collisions between asteroids or the slow release from comets. It reflects starlight and forms a soft glow around distant systems, hinting at ongoing processes in those regions. The Great Wall is a large structure in the cosmos, a vast filament of galaxies stretching over 500 million light-years. It is part of the cosmic web, a dense gathering of matter shaped by gravity over long time, a silent landmark in the deep dark. The Lyman alpha forest refers to absorption lines created when light from distant quasars passes through many clouds of neutral hydrogen. Each cloud leaves a quiet mark on the light spectrum, forming a detailed record of intervening gas, a map written in light and shadow across billions of years. Every galaxy is surrounded by a circumgalactic medium, a faint halo of gas extending beyond visible stars. This gas acts as a reservoir, feeding star formation and carrying material back outward. It is a quiet boundary between the organized galaxy and the wider intergalactic space. The universe remains a place of enduring order where light and matter follow paths shaped by time and gravity. Even as the mind rests, these systems continue, unhurried. Dust gathers, stars shine, photons travel, the deep sky holds its calm. Within a solar system, the Goldilocks zone is the region where temperatures may allow liquid water on a planet's surface. It depends on the star's size and warmth. For cooler stars, the zone lies closer. For brighter stars, it lies farther out. A quiet region of balance where conditions may remain steady over long time. Some planets become tidally locked, rotating at the same rate they orbit. One side faces the star continuously, while the other remains in darkness. Between them lies a band of twilight that does not move. Day and night settle into a single, lasting pattern. In distant galaxies, quasars shine as extremely bright centers powered by supermassive black holes drawing in matter. As gas falls inward, it heats and emits intense light. Though far away, quasars appear as faint points to us, their ancient brightness arriving across billions of years. Gamma-ray bursts are intense flashes of high-energy radiation lasting only seconds, releasing enormous energy. They are associated with events like massive stars collapsing or neutron stars merging. From Earth, they are detected through instruments rather than sight, as our atmosphere shields us. Distant and brief, known through quiet data. Gravitational waves are ripples in space-time produced by massive events, such as black holes orbiting and merging. They travel at the speed of light, gently stretching and squeezing space as they pass. The effect is so small that detecting it requires extremely sensitive instruments. As matter approaches a black hole, it can experience spaghettification, a stretching caused by differences in gravitational pull across an object. Gas can be drawn into long strands, joining the swirling material near the event horizon. Form changes under gravity's total influence, reshaped into delicate patterns before crossing into darkness. Some planets are rogue planets, drifting without a star. They may have been ejected from their systems or formed independently. Without starlight, they travel through deep darkness, frozen and quiet. There may be many within our galaxy, unseen worlds following slow paths between stars. The Bota's void is a large region of relative emptiness, roughly 330 million light-years across, containing far fewer galaxies than expected. It is one of the more striking voids in the observable universe, a vast hollow in the cosmic web where matter is sparse. Between galaxies lies the warm-hot intergalactic medium, a diffuse plasma in filaments. Though extremely thin, it contains a significant portion of ordinary matter. Heated by large-scale processes, it forms an invisible network connecting cosmic structures. To measure distances to nearby stars, astronomers use parallax, the apparent shift in a star's position when viewed from different points in Earth's orbit. The effect is small but measurable, and simple geometry turns that shift into a distance. A quiet method for mapping our neighborhood in space. The journey through the stars continues, steady and patient. Each discovery reveals another layer of enduring stillness, another quiet law shaping light and matter. And everything continues, as it always has, without hurry. Within the quiet relationship between the Earth and the Moon, there is a hidden point of balance that guides their shared movement through the dark. Although we often picture the Moon circling the Earth, both bodies actually move around a common center of mass, known as the barycenter. This point currently lies just beneath Earth's surface, around 1,700 kilometers deep. As the Earth turns, it performs a subtle, rhythmic wobble around this internal anchor, a calm coordination that keeps the two worlds gently bound together. As the Moon continues along its orbit, it exerts a soft but persistent pull on Earth's oceans, giving rise to the tides. These forces do more than shift water back and forth. They also act as a quiet brake on Earth's rotation, slowly transferring energy away from the planet's spin. Because of this interaction, Earth's days are gradually lengthening by about 2 milliseconds every century. The change is far too small to notice in daily life, yet it reflects the patient way celestial relationships evolve over immense stretches of time. While Earth's rotation slows, the Moon itself is undergoing a gradual change, drifting slowly farther away. Each year, the distance between Earth and the Moon increases by about 3.8 centimeters, a pace similar to the slow growth of human fingernails. This steady retreat has been unfolding since the Moon first formed. Over the distant future, it will appear slightly smaller in the sky, a quiet marker of its long, measured journey outward. Farther out in the solar system, the planet Mars holds vast and silent landscapes, including Olympus Mons, the largest known volcano in the solar system. This immense shield volcano rises about 25 kilometers into Mars's thin atmosphere, nearly 3 times the height of Mount Everest. Its base is so wide that it would cover an area close to the size of the state of Arizona. It stands unmoving in the red dust, a calm reminder of ancient geological forces that once shaped the planet's surface. A day on Mars, known as a sol, follows a rhythm that feels gently familiar. Lasting about 24 hours and 39 minutes, it is only slightly longer than a day on Earth. The sun rises and sets at a nearly matching pace, casting pale pink light at dawn and soft blue tones at sunset. This repeating cycle unfolds quietly across craters and plains, offering a subtle sense of shared timing between our world and its neighbor. In contrast to Mars's steady pace, the giant planet Jupiter spins with remarkable speed, completing a full rotation in just under 10 hours. Despite its enormous size, it is the fastest spinning planet in the solar system. This rapid motion stretches its atmosphere into the broad, colorful bands visible from afar. Within the clouds, movement is constant and fluid, while the planet itself follows its long orbit around the sun with a slow, dignified calm. Within Jupiter's atmosphere lies a vast and enduring storm known as the Great Red Spot. Larger than Earth itself, this swirling system has been observed for at least 3 centuries. It turns slowly, its deep red tones shaped by complex chemistry high in the clouds. From a distance, it appears almost still, a familiar feature that has remained through generations of quiet observation. Saturn carries an unusual physical quality. Its average density is lower than that of water. In theory, if an ocean large enough existed, Saturn would float. This lightness comes from its composition, made mostly of hydrogen and helium. It is a planet of great size and gentle substance, moving through its nearly 29-year orbit like a vast, luminous presence suspended in space. Though Saturn's rings may appear solid from afar, they are shaped by the subtle influence of small moons that orbit within and near the ring gaps. These shepherd moons gently guide the particles with gravity, keeping edges defined and forming delicate waves and spirals in the dust and ice. It is a quiet choreography, an ongoing balance that preserves the ring's graceful structure. Among Saturn's many moons, Enceladus stands out as a small icy world with a hidden interior. Beneath its frozen surface, a global ocean of liquid water is thought to exist. At its southern pole, geysers occasionally release water vapor and ice grains into space, forming soft plumes that rise hundreds of kilometers above the moon. Some of this material settles into orbit around Saturn, adding to its outer rings. It is a gentle exchange between a tiny moon and its vast surroundings, a quiet process unfolding in the cold stillness of the outer solar system. Europa, one of Jupiter's moons, rests in the quiet cold of the outer solar system. Its surface is wrapped in a bright shell of cracked ice, marked with long lines and gentle fractures. Beneath that frozen layer, it is believed there is a deep ocean of liquid water, hidden from the sun's direct light. This water is thought to remain warm not through sunlight, but through tidal heating, the slow, rhythmic flexing caused by Jupiter's immense gravity. In that continual darkness, the ocean can remain fluid and calm, a sheltered reservoir held in quiet balance. Farther away, Saturn's largest moon, Titan, offers a landscape that feels faintly familiar and yet entirely its own. Its air is thick with nitrogen, and the cold is so deep that water behaves like solid stone. Here, it is liquid hydrocarbons, methane and ethane, that flow through valleys and gather into lakes and rivers. A hazy orange sky hangs overhead. Clouds drift slowly, and at times a gentle rain falls, settling into dark, still pools. It is a world that echoes Earth in shape, while moving to a different, quieter rhythm. Pluto, once counted among the major planets, is now understood as part of a wider family of dwarf planets. It moves through the distant cold on a long orbit that takes about 248 Earth years. The change in classification does not alter the quiet presence of this small, icy world. Its surface holds mountains and plains of frozen nitrogen, shaped into its own subtle geography. Pluto remains a steady marker at the edge of our Sun's influence, opening the way toward deeper darkness beyond. Beyond Neptune lies the Kuiper Belt, a broad region filled with millions of icy bodies, remnants from the solar system's earliest days. Here, space is sparse, and the Sun appears only as a very bright star. Objects drift in slow, patient paths, continuing their motion over billions of years. The Kuiper Belt is a kind of frozen archive, holding traces of the solar system's beginnings in a quiet ring at the frontier. Farther still, surrounding the solar system like a distant shell, is the theoretical Oort cloud. It is thought to contain countless icy objects so far away that they are only loosely held by the Sun's gravity. They remain in near suspension, resting at the edge of what the solar system can hold. From this distant region, comets may begin their long inward journeys, set in motion by the smallest gravitational nudge, traveling for centuries toward warmer light. When astronomers study distant stars, they sometimes find planetary systems arranged in surprisingly compact ways. In some, several worlds orbit their star much closer than Mercury orbits our Sun. Their years pass quickly, yet their paths can remain stable and orderly. From the surface of one of these planets, neighboring worlds might appear as large, steady disks in the sky, close companions moving together in a tight, rhythmic pattern around a distant source of light. Some worlds follow an even more unusual arrangement, orbiting two stars in a binary system. In these places, two suns rise and set in slow coordination, shaping daylight in a gentle complexity. Double shadows can fall across the landscape, and the color of the sky may subtly shift as the two stars change their positions. Even with this added motion, the orbits can remain predictable and calm, held in place by the steady mathematics of gravity. The number of confirmed exoplanets has now grown into the thousands, revealing a quiet diversity beyond the solar system. Some worlds are made mostly of gas, others are rocky, and some may hold deep oceans or be covered in ice. Each one is shaped by its distance from its star and the materials available at its formation. This growing catalog suggests a universe filled with many different kinds of places, each a separate reality, existing calmly in its own orbit. Among these distant planets are worlds with remarkably short years, completing an orbit in only a few Earth days. Some are known as hot Jupiters or super-Earths, moving extremely close to their stars. Their motion is swift, yet smooth and constant, held firmly by strong gravity. Their lives unfold in a steady cycle of light and heat, where time is measured in days rather than months. Other planets travel along long stretched paths known as highly elliptical orbits. These journeys carry them far into the cold outer regions of their systems, before drawing them back toward the warmth of their star. Such worlds can experience seasons that last for many years, moving from brief, intense warmth into long, quiet cold. Their rhythm becomes one of gradual contrast, a patient oscillation between light and darkness, repeating without hurry across time. Brown dwarfs are often described in the quiet language of astronomy as failed stars, existing in the gentle space between the largest gas giants and the smallest true suns. They form from the same clouds of gas and dust as stars, yet they never gather quite enough mass to ignite the steady process of hydrogen fusion. Rather than shining brightly, they remain in a state of glowing embers, resting in the cool shadows of the galaxy. Neither fully planet nor fully star, they persist in a calm and enduring balance. These objects glow faintly in infrared light, a wavelength invisible to human eyes but clearly seen by sensitive telescopes. Without sustained fusion at their cores, brown dwarfs spend their long lives cooling slowly, releasing the heat gathered during their formation over billions of years. This cooling unfolds gently, like a prolonged twilight stretching across eons. In the deep dark, they move with quiet dignity, their warmth fading gradually, never in a hurry. Throughout the galaxy, many systems form not as single objects, but as quiet families of different members. Some include brown dwarfs alongside stars and planets, all held together by the soft and constant influence of gravity. Each body follows its own stable path, moving in coordination with the others. These mixed systems reflect the wide range of outcomes in the universe's creative process, where every object, no matter how dim, plays its part in a larger harmony. Over vast spans of time, star clusters slowly change. Individual stars may drift away under the subtle pull of the surrounding galaxy, a process known as evaporation. It happens so gradually that billions of years can pass before the cluster's shape noticeably shifts. Stars leave one by one, not abruptly, but through a calm transition into independent journeys. The cluster gently thins, its members finding new paths through the Milky Way. In the ancient and sparse regions known as galactic halos, old stars and clusters move along long sweeping orbits that rise above and dip below the main galactic disk. These stars formed in an early era when the universe itself was young. They travel far from the crowded spiral arms, drifting through wide, open space with measured motion. From these distant paths, they trace the slow rotation of the galaxy, like quiet sentinels in its outer reaches. Large galaxy clusters are more than gatherings of individual galaxies. They are filled with extremely thin, hot gas that stretches between the galaxies themselves. Though nearly a vacuum, this gas is warm enough to emit X-rays, revealing the deep gravitational structure of the cluster. It settles into the cluster's gravitational well, forming an invisible sea that surrounds the galaxies and moves with them, steady and pervasive. When massive galaxy clusters pass through one another, a subtle separation takes place. Dark matter, interacting only through gravity, moves onward with little resistance. The hot gas, however, interacts and slows, becoming separated from the dark matter and the stars. This quiet divergence unfolds over millions of years, offering a rare view into the universe's hidden structure and the distinct roles played by its unseen components. On even larger scales, galaxies gather into superclusters, loose associations of many clusters spread across hundreds of millions of light years. These immense groupings are not tightly bound, but they move together within the overall expansion of space. They form the broad continents of the cosmos, defining the largest patterns we can observe, shaped slowly by gravity over deep time. Between these superclusters lie vast regions of lower density, creating a structure often described as the cosmic web. Matter gathers along long filaments and dense intersections, while the spaces between remain almost empty. This immense network is a quiet record of the universe's history, shaped by gravity and expansion since the earliest moments. It is a delicate framework of light and darkness, holding the largest structures in place. Across this web, galaxies continue to form, stars ignite, and planets settle into their paths. Each new light and each quiet orbit becomes part of the ongoing story of the universe. Nothing rushes toward an ending. The cosmos unfolds with patience, its vast structures evolving slowly, balanced between light and dark. The light continues its long journeys. The dust drifts without sound, and the great web of the universe remains, resting in its quiet and magnificent stillness. In the quiet reaches of the galaxy, there are planets so rich in carbon that their interiors may be formed largely of diamond. One such world, known as 55 Cancri E, orbits its star at an extremely close distance, where surface conditions reach intense heat. Under such pressure and temperature, carbon deep within the planet may crystallize into a solid, precious form. This small world follows its tight orbit in constant brilliance, a hidden jewel moving silently through the dark, reminding us of the remarkable ways matter can transform across the cosmos. Although the vacuum of space carries no sound, stars themselves are not truly still. They vibrate gently with internal rhythms, a phenomenon known as asteroseismology. These motions arise from sound waves moving through a star's dense, glowing interior. By observing slight changes in a star's light, scientists can translate these vibrations into slow, measured frequencies. It is a quiet resonance, revealing the structure of a star from within, a steady harmony that has persisted for billions of years. When astronauts return from spacewalks, they sometimes describe a faint scent clinging to their suits, often compared to heated metal or welding fumes. This subtle aroma is thought to come from polycyclic aromatic hydrocarbons, tiny soot-like particles that drift between the stars. These molecules are remnants of ancient stellar processes, lingering in the void until they meet the air inside a spacecraft. It is a gentle chemical trace of the deep sky, a quiet way the cosmos briefly reaches the senses. Within the Eagle Nebula stand immense columns of gas and dust known as the Pillars of Creation. Rising for several light years, they form monumental shapes in the interstellar dark. Inside these cold, dense regions, gravity draws material together, slowly forming new stars. At the same time, nearby starlight gradually erodes the pillars, a process unfolding over millions of years. They mark a place of transition, where ancient dust is patiently reshaped into new light. While most stars move along stable paths within their galaxies, some travel fast enough to escape entirely. These hypervelocity stars are believed to have been cast outward after close encounters with supermassive black holes at galactic centers. Moving at extraordinary speeds, they cross the galaxy and continue onward into intergalactic space. Their journey becomes a silent departure, carrying them into the deep solitude between galaxies. The relationship between gravity and time is so subtle that time itself flows at slightly different rates across Earth. Because gravity is weaker at higher altitudes, a clock on a mountain runs just a fraction faster than one at sea level. This effect, known as gravitational time dilation, unfolds constantly and quietly. It suggests that time is not rigid but responsive, stretching gently in tune with the mass of the world beneath us. Stars also vary greatly in size. Our sun is steady and moderate, while others, such as UY Scuti or Stephenson 2-18, are vast hypergiants. Some are so large that, if placed at the center of our solar system, their outer layers would extend beyond the orbit of Saturn. These stars live intensely, radiating enormous energy before eventually ending their lives in supernovae. They stand as massive presences, moving through time with slow and powerful gravity. Though the Moon often seems completely airless, it is surrounded by a fragile exosphere. This extremely thin atmosphere is made of atoms so sparse they rarely collide. Elements like sodium and potassium are released from the lunar surface by micrometeorite impacts and the solar wind. This faint veil surrounds the Moon in near invisibility, resting quietly between solid ground and open space. At Saturn's north pole, a striking and persistent cloud pattern forms a near-perfect hexagon. This six-sided jet stream has endured for decades, each side stretching thousands of kilometers. Its shape is maintained by the orderly motion of Saturn's atmosphere, rotating with steady precision. At its center lies a long-lasting storm, calm in appearance from afar, revealing the quiet geometry hidden within planetary weather. Magnetars, a rare type of neutron star, sometimes experience events known as starquakes. Their extraordinarily strong magnetic fields place intense stress on the star's crust, which can fracture under pressure. When this occurs, a brief burst of energy is released as gamma rays, powerful enough to affect space far beyond the star itself. Afterward, the magnetar returns to its dense stillness, holding immense energy in silence once more. The light from these distant realities continues its gentle arrival, settling into the mind as starlight settles onto Earth after its long passage through space. From the faint atoms of the Moon's exosphere to the immense scale of hypergiant stars, everything moves with a calm and unhurried grace, held together by quiet laws that continue to shape the universe in steady balance. Within the long and quiet history of the cosmos, galaxies often grow through a process known as galactic cannibalism. This is a slow and measured unfolding, where a larger galaxy gently draws in a smaller neighbor through its steady gravitational pull. Over billions of years, the stars of the smaller galaxy gradually settle into new paths within the larger structure. It is not a violent collision, but a graceful merging, a calm gathering of matter that allows galaxies to grow while preserving the deep stillness of the sky. In a distant region of the Centaurus constellation lies the Boomerang Nebula, the coldest known natural place in the universe. Its temperature rests at just 1 degree above absolute zero, even colder than the background radiation left from the universe's beginning. This remarkable chill comes from gas expanding outward at extraordinary speed, cooling as it flows into space. It is a place of profound thermal quiet, where molecular motion has nearly slowed to a complete and peaceful pause. General relativity describes a subtle phenomenon called frame dragging, in which a massive rotating object gently pulls the fabric of space-time along with it as it spins. A planet or a black hole, simply by turning, causes the surrounding space to move in a faint, swirling motion. This effect is incredibly slight and entirely silent, a delicate reshaping of the cosmic stage. It reveals how matter and space are always in quiet conversation, influencing one another without sound or force. When astronomers map the cosmic microwave background, the soft afterglow of the early universe, they find an unusual region known as the cold spot. This area appears cooler and larger than the surrounding fluctuations, standing out in the otherwise even pattern of the sky. Its origin remains uncertain. Some suggest it may be linked to a vast cosmic void, while others explore different possibilities. It rests there as a calm anomaly, a silent irregularity in the universe's oldest light. From across immense distances, brief pulses known as fast radio bursts sometimes arrive at Earth. These signals last only milliseconds, appearing and fading almost instantly. They are thought to originate in distant galaxies, billions of light-years away from powerful and compact sources. Their exact nature continues to be studied, but their arrival feels like a quiet tap on the vastness, momentary traces of distant motion carried across the dark. High above and below the center of the Milky Way extend two enormous structures called the Fermi bubbles. Each stretches roughly 25,000 light-years, forming vast lobes of energized gas. Invisible to human eyes, they reveal themselves only through gamma rays and X-rays. They are believed to be remnants of energetic activity from the galaxy's central black hole millions of years ago, now lingering in the halo as silent monuments to an active past. Gravitational microlensing is a gentle method that allows hidden planets to be discovered. When one star passes directly in front of another from our viewpoint, its gravity briefly magnifies the background star's light. If a planet accompanies the foreground star, it creates a subtle, additional signal. This alignment is rare and fleeting, a quiet moment when geometry and gravity briefly reveal a world before the light returns to normal. The famous pillars of creation, though appearing timeless in our images, may already have changed. Some evidence suggests a supernova shockwave passed through the region thousands of years ago, potentially dispersing the structures. Because of their great distance, the light from that change has not yet reached us. We continue to see them as they once were, a reminder that the universe we observe is a gallery of earlier moments, preserved gently in light. There is a portion of the sky known as the zone of avoidance, where dust and stars within the Milky Way obscure our view of what lies beyond. Our own galaxy becomes a soft veil, hiding distant galaxies directly behind it. By using infrared and radio observations, astronomers slowly map these concealed regions. It is a quiet lesson in perspective, showing that even surrounded by light, some corners remain hidden. In the far future, the universe may approach a state known as heat death or the Big Freeze. As space continues to expand, stars will fade and galaxies will drift beyond one another's reach. Over immense spans of time, the cosmos may settle into a uniform, cold state, where energy differences dissolve and motion slows almost entirely. It is a vision of ultimate calm, a universe that has completed its long journey and come to rest. The journey through the cosmos is one of deep quiet and enduring beauty. Every galaxy, every void, and every subtle ripple in space-time contributes to a steady and balanced whole. As the light of these ancient truths continues its gentle travel through the dark, the universe remains unhurried, resting in its vast and patient stillness, far beyond the reach of the waking world. The light that began its journey billions of years ago continues to travel through the silent corridors of the void, carrying with it a quiet record of all that has been. As the world settles into deep and undisturbed rest, the universe continues its slow, measured rhythm. Stars that have burned for eons remain in steady balance, casting an ancient and gentle glow across the fabric of space and time. Within this movement, there is a sense of continuity, a knowing that the same laws shaping the first galaxies are still at work, guiding the calm drift of every atom and every world. Across unthinkable distances, the vast structures of the cosmic web hold matter in a delicate and enduring balance. Along these filaments, galaxies turn with quiet dignity, their spiral arms moving slowly through interstellar gas. Each sun and each planet finds its place within this greater arrangement, contributing to a harmony that requires no effort to sustain. The silence of space is not emptiness, but a natural stillness, a universe moving without friction, where time and distance are woven together into a single, peaceful whole. As the energy of the early universe continues to cool and stretch, space remains a steady and reliable foundation. Nebulae drift and settle, dust gathers into new worlds, and distant stars pulse in gentle rhythms, all within an unhurried calm. Nothing rushes toward an ending. Everything unfolds patiently across trillions of nights. Subtle forces connect all things, refining the stillness of the deep sky as the ages pass. In the quiet of the night, the mind can rest within this same pace. The steady ground of the earth, the thin veil of air above, and the infinite reach of the stars beyond create a feeling of belonging within something vast and enduring. The light of distant quasars, the unseen presence of dark matter, and the slow expansion of space move together in silent unity. There is nothing to seek, nothing to resolve, only the simple truth of a universe that rests in calm continuity. The stars continue to shine. The dust continues to drift. The great web of the cosmos remains at rest. Light moves onward through silent space, carrying the past gently into what lies ahead. In the deep dark, the rhythm of the universe remains steady, an eternal, unhurried breath. Stillness settles everywhere. Balance holds, and the journey continues quietly into the endless night. You've been listening to The Curious Owl. As these thoughts begin to fade, there's nothing more to follow, nothing more to hold on to. The knowledge can drift away now like quiet thoughts at the edge of sleep. Whether you're still listening or already resting, this space remains calm and unhurried. If you'd like to return for more gentle explorations, you're always welcome here. Thank you for spending this quiet moment with me. Good night.